We are studying Internet Protocol Security, and in this video we'll be studying about Encapsulation Security Protocol of IPSec, which is ESP. So as we have seen in the previous video that IPSec is providing two protocols here, Authentication Header Protocol and ESP Protocol. So Authentication Header Protocol does not provide confidentiality, and it only provides you data origin authentication and data integrity. But IPSec later define an alternative protocol which is called as Encapsulating Security Protocol, that is ESP, that provides the data origin authentication, integrity and privacy. So the services which are provided by Encapsulating Security Payload Protocol are data confidentiality, then limited traffic flow confidentiality, data integrity, data origin authentication, anti-replay protection, but it does not protect the IP header. So ESP adds the header and trailer. So instead of authentication header, it was only adding the authentication header. Header was there, whereas ESP is adding header and trailer both. So ESP's authentication data are added at the end of the packet, which makes its calculation easier. So here in this figure, you can see the location of ESP header and trailer. So when the IP datagram carries the encapsulating security payload header and trailer, the value of protocol field of IP header is 50. Remember, in the authentication header protocol, the value of protocol field of IP header was set to 51, whereas when the IP datagram is carrying ESP, then in that case the value of protocol field of original IP header is to be replaced with the value 50 and a field inside the ESP trailer, which is called as the next header field. See here we have a next header field. In case of authentication header also there was a next header field. So here this next header field is added in ESP trailer, which is actually carrying the original value of protocol field of IP header, which will give you the information that which upper layer payload that IP packet is carrying, TCP, UDP, ICMP or OSPF. Okay, and then the protocol field in IP header is to be set to 50. And the field inside the ESP trailer, next header, is holding the original value. Okay, so the ESP procedure follows these different steps. So for adding the ESP, we have to follow these steps. So first the ESP trailer is to be added to the payload. Then the payload and the trailer are encrypted. Then the ESP header is to be added. Then the ESP header, payload and ESP trailer are used to calculate the authentication data. And then the authentication data is added to the end of the ESP trailer. And then the IP header is added after changing the protocol value to 50. So see here, you can see first the ESP, what we are doing is first we are adding here the ESP trailer value to the payload, and then the payload and the trailer are encrypted. See this. This payload and trailer are encrypted to achieve confidentiality. Then the ESP header is to be added. Then the ESP header, payload and the ESP trailer are used to create the authentication data. And then the authentication data is to be added at the end of ESP trailer. And then the IP header is to be added by replacing the value to 50. And the different fields here in the ESP header and trailer are same, like security parameter index, the one which we have seen in AH also. It is a 32-bit security parameter index. It is a virtual circuit identifier. And then it is same for a particular session. Then we have a sequence number. Again, it is a 32-bit field. The sequence number is basically used for providing the ordering information of datagrams at the receiver side. Even if the datagram or the packet is resend, then in that case, the security sequence number will not be repeated. We'll use the new sequence number even if the packet is resent. And once the sequence number reaches 2 raised to 32, we have to establish a new connection. We cannot restart it. Then we have padding. So this is a variable length field, and all zeros is to be padded here. Then pad length is the 8-bit pad length field, which defines the number of padding bytes required, and the value can be between 0 to 255. The next header field is the, as you know, that it is a 8-bit next header field, which is similar to the one which we have seen in the authentication header protocol, and it serves the same purpose as the protocol field in the IP header before encapsulation. Then we have the authentication data, ESP authentication data. Finally, the authentication data field is the result of applying an authentication scheme to parts of the datagram. And here we have to remember that the difference between AH and ESP. In authentication header, part of IP header is included in the calculation of authentication data, whereas here in ESP we are not including it. Now let us differentiate between the authentication header and the encapsulating security payload. So here IPSec supports both IP for both IPv4 and IPv6. But whereas in IPv6, authentication header and ESP are the part of extension header itself. So ESP protocol was actually designed after the authentication header protocol was already in use, and ESP does whatever AH does along with the functionality of privacy, that is confidentiality. But the question here is why do we need authentication header? So here the answer to that is, however, the implementation of, we actually don't need authentication header when we have ESP, but the implementation of authentication header is already included in some commercial products. So which means that AH will remain the part of internet until these products are in use. Then the services which are provided by IPSec are the two protocols, AH and ESP. So access control is provided by both. Message authentication, message integrity is provided by both. Then entity authentication is provided by both, whereas confidentiality is not provided by AH, but it is provided by ESP. And both of them are providing the replay attack protection. So here access control indicates that IPSec provide access control indirectly using the security association database. So that we are going to see in the further slides, that how it is providing access control through security association database. And we'll also see that when a packet arrives at a destination and there is no security association established for that packet, then the packet would be discarded. Then message integrity can be provided in both by the message digest of the data which is created and sent by the sender. Then authentication, security association, and the keyed hash digest of the data which is sent by the sender authenticates the sender of the data in both AH and ESP. Whereas confidentiality is only provided in ESP, and AH, however, does not provide confidentiality. If the confidentiality is required, we have to use only encapsulation security protocol. As it is providing replay attack protection, both of them are providing. So in the next video, we'll see how it is protecting the replay attack.